We've seen queries before, but now let's look at them in a whole new light. Welcome to this video on querying SQL Server. My name is Kevin Fiesel. I am the proprietor of Galaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. In the last couple of videos, we've looked at a variety of queries on a SQL Server instance, learning a bit about the T-SQL language, different clauses and operators, and joins. Well, now we're going to look at these queries from a different angle: how the database engine interprets the T-SQL we send in. You see, SQL is a fourth generation language. Now, when it comes to language generations, wait, my producer is telling me that I've already gone down this cul-de-sac in a prior video, so I guess I won't do that again in this one. Instead, let me summarize it by saying that we write a T-SQL query and let the database engine interpret it in toto, building a plan to give us the desired result and perform the operations necessary to enact that plan. The plan itself is what we're going to look at today: execution plans. To build a proper execution plan, you need a hangman. No, wait, wrong genre. To build a proper execution plan, you need a way of parsing the query. In SQL Server, that's called the algebraizer. We won't dig into this part of the database engine today, so for the sake of keeping this short enough for a YouTube video, we just need to understand that there is a complex software solution working behind the scenes to turn our SQL into directed actions. The good news is we can see this action pretty easily, as SQL Server exposes these execution plans as XML. So all we need to do is read several megabytes of XML. Or we could use a tool to do that for us. Probably a better idea than going stir crazy trying to read 10,000 lines of XML. Trust me, I speak from experience. So what tool can we use for the task? Well, there are a few of them, and we're already familiar with two. First up is Azure Data Studio. I put that one first because I'm going to say the least about it. Azure Data Studio has gotten better when it comes to displaying execution plans, but I think the other two tools we're going to work with today are a bit better than that. The next tool we'll talk about is SQL Server Management Studio. SSMS has had a reasonably good execution plan viewer baked in for its entire existence. The viewer has improved over the years and lets you do things like compare execution plans, view live execution of plans, and easily get the XML for the query. But the primary tool I use for serious execution plan viewing is SQL Sentry Plan Explorer by SolarWinds. This is the viewer of choice because it is so powerful. In fact, let's go to a demo and see SSMS and Plan Explorer in action. I'm going to start with a query that I used in a prior video and run it in SQL Server Management Studio. This returns 50 parking violations from Officer 32024 and also gives us the violation code and description. If I run the query, we can see that it returns results pretty quickly. But let's say I want to learn more about what SQL Server is doing to satisfy my query. In SSMS, I can select the Display Estimated Execution Plan icon or strike Ctrl-L on my keyboard and view an estimated execution plan. Doing that, Management Studio returns some interesting information to me. The first thing I will call out is that it sees the possibility of an index which could improve my query. If I right-click on the missing index text, I can choose Missing Index Details and see the index that SQL Server thinks will satisfy the query more effectively than what I have currently. I'm going to leave this alone for now. I'm sure I'll talk about indexes in a future video. The short version of my advice is that this missing index might be useful, but I'd want to understand which indexes already exist on the table, how frequently users will call this query, and if the set and order of columns on the index is appropriate. Let's now look in at the graphical query plan. One nice aspect of Management Studio is that I can click on any of the icons in the execution plan and view properties. Let's start with the select on the left. This operation took less than a second to run and returned 0 rows. Well, that's because we're looking at an estimated plan, so the query never actually ran. Instead, we went to SQL Server and said, hey, SQL Server, let's say that, hypothetically, I just wanted to run this query. what do you think you'd have to do? Then it goes into the back of the shop, opens up some well-worn catalogs full of actions, writes a few things down on paper, and comes back to me. Well, buddy, here's what I got you for. This kind of estimated plan is really useful if I'm writing out a query but don't want to run it yet because I'm concerned about data size or appropriate indexing. For example, if I select the clustered index scan icon, I can see that SQL Server is estimating that it will read 54 million rows and send back 50 total rows from those 54 million. Admittedly, this sounds a bit inefficient to me, but let's roll with it. The next thing I want to do is go back to the query and build an actual execution plan. I can do that by selecting the Include Actual Execution Plan icon or striking Ctrl-M on the keyboard. When I do this, you can see that the button is depressed in SSMS, but it didn't actually run anything. Unlike the Estimated Execution Plan button, this doesn't immediately run anything. Instead, it says that, until I turn the setting off, every query will now display its actual execution plan. If I run this query again, I get an execution plan tab and can see some interesting results. We see times and numbers for each element of the execution plan, 50 of 50 rows taking a certain amount of time. We also see a cost associated with each operation. These costs aren't always accurate. Sometimes a high-cost operation may be hidden and trick the database engine into thinking it's a low-cost operation. But most of the time, this is a good indicator of where the pain points in a query are. If I click on the select icon again, we can see 50 rows returned, indicating that the query actually ran this time. Now, for reading an execution plan, there are two ways to do it: left to right or right to left. Both are valid and tell you interesting information. Reading this left to right gives you an idea of the order of operations, which I'd liken to commands in a corporate environment. The select operator is the CEO. It kicks us off and then says to the top operator, "Hey, do you have any rows to give me?" Top, knowing that it's supposed to get up to 50 rows based on the top expression we see in the properties, tells select to wait a moment as it talks to its subordinates. Its subordinate is a nested loops join, one of 3 different join types in SQL Server. Nested loops here is kind of like a middle manager. It takes the output of its subordinates, smooshes it together, and presents that output as its own handiwork. Top says, "Hey, nested loop, give me a row." Well, in order to get the data to do its job, it needs to kick its 2 subordinates, a clustered index scan on parking violations and a clustered index seek on violation. The way it does so is as follows. Nested loops calls up parking violations and says, "Give me a row matching your predicate." In SSMS, we can select the ellipsis next to the predicate and see that this is a filter where officer ID is 32024. The clustered index scan means that we need to scan through this table from start to finish. The clustered index scan begins and keeps scanning until it finds a row associated with its predicate. It then returns that row to its boss and goes back to looking at pictures on Instagram. In the meantime, nested loop calls its other subordinate, violation, and says, "Hey, violation, here's a violation ID for a row. Give me the code in the description." The clustered index seek here means that we have an index that violation can look at, so it's able to return back any rows associated with that violation ID pretty easily. Because this is a lookup table, we know that there will be at most 1 row that violation returns. Now that nested loops has a row from both tables, it can smoosh them together and present the row back to top, which presents it to select. This process continues until we find the 50th row, at which point top says, "The boys have done a great job, and go ahead and take the afternoon off." So that's one way of looking at this execution plan. The other way that we look at these plans is right to left, which gives you a feeling for the data flows along the way. Starting in the top right, we see a clustered index scan of parking violations, which returned 50 rows. SQL Server, during the estimated plan creation, thought that it would need to read all 54 million rows. It turns out that it only needed to read 235,216 rows. That's not nearly as bad, though it's also not great. It means that we had almost 235,200 rows read for no good reason, knowing that we only needed 50 of them. If I mouse over the big arrow, we can see this detail here. Thus, if I were looking for a way to improve performance on the query, that's the area where I would start. Too many rows being read to satisfy the nested loop join. Before I go on, one last thing we can do is to get this plan in XML format. If I right-click in the canvas, I can show the execution plan XML. This pops up the execution plan in XML format. This is a fairly simple plan with just over 150 lines, but as you write more complex queries, the plan size can grow considerably. That's why it's so important to have a good graphical tool for analyzing complex plans. Now that we've gotten the story of how execution plans work, I'm going to bring us over to SQL Sentry Plan Explorer, a SolarWinds tool which does an excellent job of analyzing execution plans. This tool is free to use, and I've been an avid fan of it since it came out, well over a decade ago. If I paste in the same query and execute it in this tool, I get a message indicating that it won't actually display any results here. Plan Explorer is not a general purpose querying tool. It's a diagnostic tool for query tuning. So we don't actually care what the results are, just how long it took to get them. After running, we can see that the shape of the plan is the same. That's because SSMS and Plan Explorer both read from the same XML that the database engine generates. But as we can see, each tool surfaces the data in a different way. I have a couple of exclamation points I can see, one on select and one on the clustered index scan. If I mouse over the select operator, it's telling me that SQL Server indicated a new index could help out this query. Right-clicking on the operator will allow me to expose those missing index details. Then, if I hover over the clustered index scan, I see a message about residual I/O. In other words, Plan Explorer caught on to the fact that SQL Server needed to read 235,216 rows in order to give me back the 50 that I need. If you see residual I/O like that, it's a good sign that either you're missing an index or that the index the database engine is using isn't quite good enough to solve the problem efficiently. There's a lot more to Plan Explorer that I like, but the last thing I'll mention here is the outputs above. Something I really enjoy about Plan Explorer is that I can easily see several measures for each statement in my batch, which is especially important when you're query tuning and you have several variants of the same query in an attempt to get the fastest response. The compile time tells us how long the database engine spent building out an execution plan, 9 milliseconds in this case. The duration is wall clock time. It took 43 milliseconds to finish this task. CPU tells us how much CPU time the database engine spent. Because this was a non-parallel query, my CPU time is no greater than the actual duration. For parallel queries, we can easily see CPU time as a multiple of duration. We can also see that the query required 3,536 reads of table pages, as well as 0 writes. All of these measures are easily comparable, making it useful for me as a query tuner. And that'll do it for this demo. I'm not going to get into query tuning today, nor will I put together a compendium of operators. Those are things we'll talk about in future videos. Someday. Probably. Over the course of this video, we got to see 2 tools designed for working with execution plans, SSMS and SQL Sentry Plan Explorer. Reading execution plans is an important part of query tuning, and we'll go back to that well over and over, I'm sure. But for today, I just wanted to give you a primer on the topic. We'll have links and show notes in the descriptions below. And until we see each other in the next video, take care.